Most people wake up in the morning, silence their alarm, scroll through their phone for a few minutes, and then shuffle to the bathroom to start the day. That sequence feels normal. But here is what most people do not realize. In the critical window between when you first open your eyes and when you finally stand up and move, your fasting blood sugar is at its peak of the entire day, and it is climbing. The reason for that climb has nothing to do with what you ate the night before. It is driven by a set of hormones your body releases every single morning to prepare you to wake up. And there is one thing that takes less than 5 minutes and costs absolutely nothing that can counteract that climb directly, measurably, and through mechanisms that medical science has confirmed. At the molecular level, that thing is a specific sequence of morning stretches, performed before you eat, before you drink your coffee, and ideally before you fully stand up. Today's video is going to explain exactly why this works, what the numbers say, which specific movements matter most, and how to build this into a routine that becomes as automatic as brushing your teeth. Before you can appreciate what morning stretching does, you need to understand why your blood sugar is elevated in the first place when you wake up. The answer is something called the dawn phenomenon. Between roughly 3 and 4 in the morning, 4 hormones begin rising simultaneously. In preparation for waking: cortisol, growth hormone, glucagon, and epinephrine. Each of these hormones plays a role in elevating blood glucose to provide your brain and muscles with the fuel needed to transition from sleep to activity. Cortisol signals the liver to break down stored glycogen into glucose and release it into the bloodstream. Growth hormone temporarily reduces tissue sensitivity to insulin, meaning the glucose that enters the blood is less efficiently processed. Glucagon directly stimulates hepatic glucose production. Epinephrine adds a further layer of glucose release from both the liver and muscle tissue. By the time you open your eyes, all 4 of these hormones have already been working for 1 to 2 hours. In a person with excellent metabolic health, this glucose is quickly processed when insulin is released. But in someone with even mild insulin resistance, prediabetes, or type 2 diabetes, this morning glucose surge can persist for hours after waking. According to the 2024 Korean diabetes statistics, 15.5% of adults over 30 have diabetes, and only 15.9% of diagnosed patients are achieving integrated blood glucose management goals. The dawn phenomenon is one of the most common reasons morning fasting glucose readings remain high despite good evening and nighttime behavior. Understanding this is the first step, because the solution is not medication. The solution is moving the right muscles in the right sequence within the first minutes of your morning. Here is the foundational science you need to know. Skeletal muscle is the single largest glucose disposal organ in the human body. After a meal, over 80% of blood glucose is taken up by skeletal muscle through insulin-stimulated pathways. Your muscles, all 640 of them combined, represent an enormous reservoir for glucose storage and consumption. The protein that acts as the gateway for glucose to enter muscle cells is called GLUT4, the glucose transporter type 4. In a resting, non-stimulated state, GLUT4 is stored inside the cell. When insulin arrives and binds to muscle cell receptors, a signaling cascade moves GLUT4 to the cell surface, where it creates channels for glucose to flow inside. This is how insulin clears blood glucose after a meal. But here is the discovery that makes morning stretching so powerful and so specific. When muscle fibers contract and stretch, GLUT4 moves to the cell surface through a completely separate pathway that does not require insulin at all. This is called insulin-independent GLUT4 translocation, and it is mediated through AMPK activation, ACT-MAPK signaling, and mechanical stretch-induced reactive oxygen species. A study published in a physiology journal confirmed that passive stretching in skeletal muscle produces ACT-dependent and P38-MAPK-dependent augmentations of GLUT4 translocation and glucose uptake. Another study demonstrated that AMPK activation and stretch independently and additively recruit contraction-mediated glucose transport, and that this pathway is fully functional, even when insulin signaling is blocked. This last point cannot be overstated. In insulin-resistant individuals, insulin's ability to move GLUT4 to the cell surface is impaired. But the stretch-contraction pathway for GLUT4 translocation is not impaired by insulin resistance. It works through entirely different molecular machinery. This means that morning stretching represents a form of blood glucose management that directly bypasses the broken insulin pathway. In metabolically compromised individuals, now let us look at what the numbers actually show. A 2024 systematic review and meta-analysis, pooling data from over 700 participants, with an average age of around 57, found that stretching exercise acutely decreases blood glucose levels and, over time, chronically improves glycated hemoglobin, which is HbA1c. An earlier randomized within-participant experimental study involving 22 adults, either at increased risk of type 2 diabetes or diagnosed with type 2 diabetes, found that 20 minutes of passive static stretching lowered blood glucose values to a meaningfully greater extent than doing nothing. In research specifically examining the soleus muscle, a deep calf muscle, with an exceptionally high proportion of slow-twitch oxidative fibers, a soleus push-up exercise, which is essentially a seated calf raise movement, produced a 52% improvement in blood glucose excursion and a 60% reduction in insulin response. A separate finding showed that performing seated calf raises for 3 minutes every 30 minutes reduces insulin response by 26%. These are not trivial numbers. A 52% improvement in blood glucose variability from a simple calf movement is a result that most pharmacological interventions would envy. The mechanism is the same insulin-independent GLUT4 activation pathway, applied to one of the most metabolically active muscles in the lower body. The 5 pathways through which morning stretching lowers blood glucose deserve a detailed walkthrough, because understanding them helps you perform the movements with intention, rather than just going through the motions. The first pathway is direct insulin-independent GLUT4 translocation, which we have already described in detail. Mechanical stretch and contraction activate AMPK signals GLUT4 to move to the plasma membrane, and glucose flows into the muscle cell, without needing insulin to initiate the process. The second pathway is enhanced local blood flow to working muscles. When you stretch a muscle, blood flow to that tissue increases substantially. More blood flowing through muscle tissue means more glucose molecules physically passing by GLUT4 channels at the cell surface, increasing the rate of glucose uptake simply through greater contact and concentration gradient. Enhanced blood flow also improves the delivery of whatever insulin is present in the circulation, meaning even the existing insulin-mediated GLUT4 pathway functions more efficiently. The third pathway is blunting of hepatic glucose output. The liver is a major driver of the dawn phenomenon, releasing stored glycogen as glucose into the blood. Under hormonal instruction from cortisol and glucagon, physical movement, even light stretching, activates counter signals through sympathetic nervous system engagement and energy expenditure that reduce the liver's drive to release excess glucose. A study examining morning exercise before breakfast observed that moderate aerobic exercise in the morning helped reduce the blood glucose rise associated with the dawn phenomenon. The fourth pathway is short-term and cumulative improvement in insulin sensitivity. A single exercise bout increases muscle glucose uptake capacity for 24 to 48 hours through GLUT4 upregulation, AMPK activation, and mitochondrial biogenesis. Performing morning stretching every day means the glucose uptake window from each session overlaps with the next, creating a cumulative background improvement in insulin sensitivity. One research program found that just 7 consecutive days of exercise improved insulin sensitivity by 58% in previously sedentary individuals. The fifth pathway is cortisol modulation. Stretching paired with diaphragmatic breathing activates the vagus nerve and shifts the autonomic nervous system toward parasympathetic dominance. Parasympathetic activation suppresses cortisol secretion, which reduces the cortisol-driven liver glucose release that is one of the primary mechanisms of the dawn phenomenon. This means that the breathing technique used during stretching is not incidental. It is an active component of blood glucose management. Now let us go through the specific 6-movement morning stretching routine. This sequence is designed to activate the largest glucose-consuming muscle groups in the body, in a progression that takes between 7 and 10 minutes total, and can be performed entirely in your bedroom. No equipment is needed. You should not sweat. You do not need to change clothes. The first movement is the supine knee to chest pull. Lie on your back on the bed or a mat. Slowly draw both knees toward your chest, placing your hands behind your knees or on your shins. Hold this position for 30 seconds while breathing slowly. 4 counts in through the nose and 6 counts out through the mouth. Release and rest for 5 seconds, then repeat once more. Total time is approximately 75 seconds. This movement contracts and stretches the hip flexors, abdominal muscles, and lower back muscles simultaneously. These are large muscle groups with significant glucose storage capacity. Their activation immediately begins the GLUT4 translocation process, and the sustained hold allows blood flow to increase to the working tissue. The second movement is the soleus activation sequence. Sit on the edge of the bed or a chair with both feet flat on the floor. Begin by slowly rotating each ankle, 10 times clockwise and 10 times counterclockwise. Then, with your heels fixed on the floor, raise your forefoot as high as possible and lower it 20 times. Follow this with heels raised and forefoot fixed for 20 repetitions. Total time is approximately 90 seconds. As established by the research above, the soleus is among the most powerful glucose consumers per unit of activation in the entire body, because it is a predominantly slow-twitch muscle, designed for sustained activity. It can absorb glucose continuously, and maintains elevated GLUT4 activity for extended periods after stimulation. The 52% blood glucose variability improvement found in the soleus push-up research makes this the single highest impact movement in the entire routine, relative to its effort and time cost. The third movement is the standing quadriceps stretch. Stand and hold the wall or bed frame for balance if needed. Bend one knee, bring your heel toward your buttock, and hold your ankle with the same side hand. Pull the heel toward the glutes, until a strong stretch is felt along the front of the thigh. Hold 30 seconds, switch sides, and hold another 30 seconds. Total time is approximately 75 seconds. The quadriceps represent one of the 2 largest muscle groups in the human body. Their combined glucose storage capacity and uptake rate is exceeded by no other single muscle group. Stretching the quadriceps increases blood flow to this enormous tissue mass and activates GLUT4 through the mechanical stretch pathway, effectively opening the largest possible glucose sink available in the morning. The fourth movement is the standing hamstring stretch. Stand and extend one leg forward with the heel on the floor, and the toes pointing upward. Hinge forward at the hip with a flat back, pushing the chest forward rather than rounding the spine, until a strong stretch is felt along the back of the extended thigh. Hold 30 seconds, switch sides, hold 30 seconds. Total time is approximately 75 seconds. The hamstrings run along the posterior thigh and, together with the quadriceps, make up the bulk of the lower body's muscle mass, activating both the quadriceps and hamstrings in sequence in the same morning session creates a compounded effect on total lower body GLUT4 mobilization, giving the body's largest glucose processing organs a full activation signal before any food has been consumed. The fifth movement is the standing calf raise. Stand with both feet flat on the floor, or with the balls of the feet on the edge of a step. Slowly raise both heels as high as possible. Pause for 1 second at maximum contraction, then lower slowly. Perform 15 repetitions at a controlled pace, then 15 additional repetitions at a slightly faster pace. Total time is approximately 60 seconds. Unlike the seated soleus activation, the standing calf raise primarily targets the gastrocnemius, the larger outer calf muscle. The gastrocnemius and soleus together form the lower leg's muscle pump, which returns venous blood from the lower extremities to the heart. Their activation dramatically improves lower body circulation and drives a significant additional wave of insulin-independent GLUT4 activity following the seated sequence already performed. The sixth movement is the standing figure 4 glute stretch. Stand and lift one foot, resting the ankle on the opposite knee. To create a figure 4 shape, slowly sit back into the stretch by bending the standing knee and pushing the hips backward, as though lowering toward a chair. Hold when a strong stretch is felt in the glute of the lifted leg. Use one hand against the wall for balance if needed. Hold 30 seconds per side. Total time is approximately 75 seconds. The gluteal muscles are among the largest and strongest in the human body, with correspondingly large glucose storage capacity. Activating them in this final position also recruits the core stabilizers, ankle stabilizers, and knee surrounding muscles, simultaneously creating a whole body activation effect to close out the routine. The total time for all 6 movements, including brief transitions, is approximately 7 to 9 minutes. This is the 5 to 10 minute morning stretching routine. Every second of it targets the specific muscle groups scientifically identified as the primary sites of insulin-independent GLUT4 mediated glucose uptake. 3 evidence-based tips will amplify the blood glucose benefit of this routine. The first is diaphragmatic breathing throughout every movement. Breathe in slowly through the nose for 4 counts, and out through the mouth for 6 counts during every held stretch position. This breathing pattern activates the vagus nerve and shifts autonomic tone toward parasympathetic dominance, suppressing cortisol and reducing hepatic glucose output, as described in the 5th pathway above. This addition costs no extra time and meaningfully enhances the hormonal component of blood glucose reduction. The second tip is drinking 200 milliliters of room temperature water immediately upon waking, before you begin stretching. Overnight respiration and mild sweating cause a level of dehydration that increases blood viscosity and reduces muscle blood flow. Rehydrating first allows the blood to flow more freely to the muscles you are about to activate, increasing the rate of glucose delivery and uptake at the GLUT4 level. The third tip is measuring your blood glucose before and 20 minutes after the routine, if you have a glucose meter. Watching your own numbers respond to this practice within days is the single most powerful habit reinforcement tool available. When you see your fasting blood glucose drop measurably after just 5 days of consistent practice, the habit becomes self-reinforcing. Here are 3 post-stretching breakfast recipes designed to extend the blood glucose benefits of the morning routine. The first is the protein-first blood sugar stabilizing breakfast. Prepare 2 soft-boiled or poached eggs, half an avocado sliced, 1 slice of whole grain toast, a handful of cherry tomatoes, and a small portion of arugula or spinach. Eat in this specific order: vegetables first, eggs and avocado second, toast last. The fiber in the vegetables physically slows glucose absorption in the small intestine. The protein and fat in the eggs and avocado flatten the insulin curve. The whole grain toast provides slow release complex carbohydrates that enter the bloodstream gradually after the muscle GLUT4 channels are still elevated from stretching. The second recipe is the blood glucose stabilizing smoothie. Blend 150 grams of plain Greek yogurt, a handful of frozen blueberries, a handful of spinach, 1 teaspoon of chia seeds, and a 1/4 teaspoon of ground cinnamon in water or unsweetened oat milk. The protein and probiotics in Greek yogurt support steady glucose clearance. The anthocyanins and resveratrol in blueberries have been associated with improved insulin sensitivity. Cinnamon contains compounds that activate insulin receptor signaling enzymes. Chia seeds form a gel in the digestive tract that slows glucose absorption. The third recipe is the traditional fermented soy morning bowl. Prepare a small bowl of miso or doenjang soup with firm tofu and bok choy, a half portion of brown rice rather than white, a soft boiled egg, and a small portion of seasoned spinach. Eat the spinach and soup first, tofu and egg second, brown rice last. Fermented soy products provide beneficial bacteria that support metabolic health. Tofu delivers protein and spermidine, and brown rice has a significantly lower glycemic index than refined white rice, producing a gentler glucose curve after the muscle uptake. Period initiated by stretching. Your 7-day action plan begins as follows. On day 1, establish your baseline. If you have a glucose meter, measure your fasting blood glucose immediately upon waking and record the number. If you do not have a meter, note your subjective morning energy, mental clarity, and morning appetite. On a scale of 1 to 10, this becomes your comparison point for the week. On day 2, perform the first 3 movements. Only the supine knee to chest pull, the soleus activation sequence, and the quadriceps stretch. This takes about 4 minutes. Beginning with half the routine lowers the barrier to entry and lets your body adapt to morning movement without overwhelming the day. On day 3, add the full glass of water upon waking before you begin the movements, and consciously practice the 4 count in and 6 count out breathing pattern during every hold. On day 4, complete all 6 movements in sequence for the first time. Do not worry about perfect form. The benefit comes from the act of contracting and stretching the target muscles, not from executing magazine perfect positions. On day 5, change your breakfast to one of the 3 post-stretching recipes above and apply the eat vegetables first, protein second, carbohydrates last meal sequencing rule. On day 6, measure your fasting blood glucose before the routine and again 20 minutes after completing it. Compare the 2 numbers. Most people see a measurable reduction. On day 7, review the week. Notice whether you are waking more easily, whether your mid-morning energy has improved, and whether your craving for a mid-morning snack has decreased. These are early signs that your morning glucose profile is stabilizing. There are 5 safety notes that must accompany this practice. Anyone taking insulin or blood glucose lowering medications must consult their doctor before using morning stretching as part of their blood glucose management. Morning exercise in a medicated state can produce unexpected low blood glucose, and medication dosing may need to be adjusted. If you experience dizziness, shakiness, cold, sweat, or heart palpitations during or after the routine, eat a small amount of food immediately and seek medical advice. People with orthostatic hypotension, the tendency for blood pressure to drop when standing, should transition from lying to sitting to standing very slowly to avoid dizziness during the movement transitions in the routine. Anyone with a recent surgical procedure, active joint injury, or musculoskeletal condition should modify or exclude movements that stress the affected area, as described in the modification section, and should receive clearance from their healthcare provider before beginning. Finally, morning stretching is one component of blood glucose management and should be understood as complementary to, not a replacement for, dietary control, sleep, stress management, and medical treatment where prescribed. Fasting blood glucose that is persistently elevated, despite lifestyle improvements, requires professional medical evaluation. The summary of today's content is this: your fasting blood glucose is elevated every morning because of the dawn phenomenon, a coordinated hormonal signal from cortisol, growth hormone, glucagon, and epinephrine that drives your liver to release glucose. Before you wake up, your body's largest and most powerful glucose disposal system is your skeletal muscle, which normally clears over 80% of blood glucose, using insulin to move GLUT4 transporters to the cell surface. Morning stretching activates a completely separate, insulin-independent pathway for GLUT4 translocation that works through mechanical stretch, AMPK activation, and P38MAPK signaling. This pathway functions even when insulin resistance is present, making morning stretching directly effective for the population that needs blood glucose help the most. The soleus muscle alone produced a 52% improvement in blood glucose variability and a 60% reduction in insulin response in published research. A systematic review and meta-analysis confirmed that stretching exercise acutely reduces blood glucose and chronically improves HbA1c. 6 targeted movements performed in 7 to 10 minutes each morning, combined with diaphragmatic breathing, morning hydration, and a protein-first breakfast, create a morning protocol that begins shifting your metabolic baseline from the very first session, and compounds its benefit with every subsequent repetition. Tomorrow morning, when your alarm sounds, before you look at your phone, bring your knees to your chest and hold for 30 seconds. That one movement begins the entire process. Your blood glucose will respond. Your body is waiting for the signal.